Look at this differential equation y prime equals xy plus y. It's basically saying the slope of the tangent line can be found with these x's and y's. So if we are going to draw a direction field, what you do is say you pick x and y points, and then by using this little formula over here, we can find out what's the slope of the tangent line, even though at this point we don't know what the original function is. So we can start picking points. So of course, if you were to consider all four quadrants, there's a lot of points you can pick. So I'm just going to concentrate right now on the first quadrant. So let's see, if I were at the point, for example, well, I guess I could start at 0, 0. So you plug in a 0 and a 0 for x and y, and it's going to give you 0. So then the slope would be 0 here. And next pick something like, well, what if we moved over a little bit? What if we went over to a half and maybe up by 1 or so? So there's a half right there. So what happens at that point right there? So if x is a half and y is a 1, so this would be a half plus a 1, so it's a 1.5 slope. So at this point, let's see, this would be a slope of 1. It needs to be a little bit steeper than that. So keep in mind that's the tangent point to some function that we can't see. Next, what if you went over to 1, 1. So 1, 1 is going to be, this is 1, and this is a 2. Well, 1 plus 1 equals 2. So over here, it's even a little bit steeper. Let's say like that. Now, keep in mind with solving a differential equation, it would have a plus c in it, at least until I plugged in these numbers and found out what c is. But right now, we're just dealing with this. That means that the actual solution has a plus c. So consequently, the actual answer may be that it's a parabola. But it could be a parabola plus c. It could be a parabola where the c is negative. Since we don't know what c is, at least not at this point, what's happening is you could be picking up on one of the parabolas and saying, oh, at this point, here is the slope of the tangent line. At this point, here's the slope of the tangent line. At this, here's the slope of the tangent line. But what you've got to do is basically follow a pattern and then realize, I'm following this parabola right here. If you jump around a lot and pick points sort of far apart from each other, you say, okay, the slope of this one is like this. And then the slope of this one is like this. Well, if you only had this and this, it's very hard to see which way is this function going. Did it go like this? Is it a circle? What's going on here? So what you've got to do is sort of pick, even though we can't see what the original function is, so we've got to sort of pick a line and go with it. So what I'm going to do is I'm going to sort of follow this one. This one is saying, okay, go here, then the next one is going to be like this. So I'm going to stick close to this one. So if I went over, so this one is telling me go up this direction. So if I went over to 1.5, then it would take me approximately to here, which I would approximate that's at 2. So then at 1.5 and 2, this would be 1.5 times 2, so that's a 3, plus 2 more is a 5. So then the slope is 5, which is pretty steep. So then if I go to 2, this thing is pointing me up here, which actually is starting to get up into the words. So then that would be something like 4. So now plug in that x is a 2 and y is a 4. We would have 8 and 4 is 12. So then you go up to this point and the slope is really steep. It's a 12. So as I've been following this thing, it's going like this. And it's getting really, really steep. The only function I know that does that is e to the x. So my guess is that y is something like e to the x. Maybe it's e to the 5x, maybe it's e to the 17x, but I think that it's e to the x. Let's see. So now we need to, over here, we're now actually going to find the function that does this. On the right-hand side, factor out y. It will leave x plus 1. Then separate the variables. So this is dy dx on the left side. So divide both sides by y. The left side will be dy over y. The right side will be x plus 1 dx. Now that the variables are separated, integrate and integrate. The left side is natural log of y. The right side is x squared over 2 plus an x plus some constant. The last thing to do is get rid of natural logs, so exponentiate both sides, and it will say y is equal to e. Sure enough, it's an e function. So the guess of the e function was right. Based on this picture, how are you ever going to guess that it's actually e to the x squared plus x plus c? No, that's why we still need math. We still need to find out c though. So this part right here is saying plug in that x is a 0 when y is a 1. So y is a 1 when x is a 0. So the x squared is gone, the x is gone, we're just left with e to the c is equal to 1. The only number that can make e disappear like that is a 0, e to the 0. So c is equal to 0. And then the final answer is that y is equal to e to the x squared over 2 plus x, and c is a 0, so that's it.